Alright, so let's look at our first example of partial fraction decomposition. Here are the steps that we're going to follow for the decomposition process. The first thing that we're going to do is we're going to take the fraction and we're going to factor the denominator completely. Alright, so looking at example 1, I have 4x minus 8 divided by x squared minus 2x minus 3. The first step is to factor that denominator completely. Alright, so I have 4x minus 8 divided by, okay, how does that factor? It has to be x and x, 3 and 1, and the signs have to be opposite. So what is that? Positive 1, negative 3. Foil that out, make sure you get back to where you started, and we do. So there's our step 1. Now, this denominator, what category does it fit into? Well, I have two linear factors because it's x to the power of 1, x to the power of 1, and each of those factors are only there one time. So the type is based upon the factor denominator. So we have non-repeated linear factors. Alright, so this is type 1. Alright, step 2 is to set up the equation. Each of those non-repeating linear factors, we're going to say equals 2, but each of those non-repeating linear factors get to become the denominator of their own smaller, what we call partial fractions. Our goal is to break down this more complicated fraction into smaller fractions. When I add these two fractions together, I should get back to the original fraction that I started with. Alright, that's our goal. So step 2 says set up the equation. Alright, so equals, that gives us an equation. We have our partial fractions with the denominators coming from those non-repeating linear factors. On top of non-repeating linear factors, we put a capital letter. We usually start with A, B, C, and so on. Okay, these letters have to be different from each other. Alright, it doesn't really matter what letter it is, but they do need to be different from each other. These letters are going to represent the numbers that are going to be the numerators of those fractions. So our goal is to figure out what is A equal to, what is B equal to. So what values would I need for the numerators? So if I add these two fractions together, give them the common denominator, then I get back to here. So that's step 2. Alright. Step 3. Step 3 says we're going to multiply the equation by the original denominator, which is what we're going to call the lowest common denominator, to get rid of the fractions. Scoot down a little bit. So we're going to multiply the equation by the original denominator, what we call the LCD, to get rid of all the fractions in the equation. Alright, now if I add these two fractions together, I would have to give them the same denominator, and this is what that denominator would look like. And we would call that the LCD. So the lowest common denominator of those two fractions. Right? Now what we're going to do is I'm going to multiply everything on both sides by that LCD to clear out the fractions. So I'm going to take a minute and I'm going to rewrite what I have up here. I'm going to give myself a little bit of room in between. Alright, so here's the LCD. And what I'm going to do is I'm going to multiply everything on both sides by that exact whole thing. If you want to think about it as LCD over 1, you can. Okay. Now I have to do that to everything on both sides, so I'm also going to multiply here by x plus 1 times x minus 3. If you want to think about that as over 1, you can. And here the same thing. Okay, so step 3 says multiply through by the original denominator in the factored form. Multiply everything on both sides, every fraction on both sides by that LCD. Okay, now we need to cancel common factors. So x plus 1 and x plus 1, those match. X minus 3 and x minus 3, those match. So we end up with 4x minus 8 equals. If we've done this correctly, then all of our denominators should go away. The next fraction, we have x plus 1. That matches an x plus 1 in the top of that fraction. So we end up with a times x minus 3. Put my plus sign there. In the next multiplication, I have x minus 3. It's going to cancel out with an x minus 3 at the top. So I have b times x plus 1. All right, so that's our equation without any denominators. Okay, step 4. Step 4 says let x be convenient values to solve for the constants a, b, and c, and so on. All right, so what does that mean? What we're going to do is we're going to take each denominator and we're going to set that denominator equal to 0, and then we're going to solve. Okay, the convenient x values, okay, let's just write this out, is an x value that causes any partial fraction denominator to be 0. Okay. So, let's go back down here. One of my denominators is x plus 1. What would cause that denominator to equal 0? What would I have to put in place of x to make that equal 0? Well, you might be able to eyeball and say, hey, that would be an x value of negative 1. That would be one of our convenient x values. Now, sometimes you have a hard time eyeballing it, and you might say, I'm not really sure. Well, there is a procedure, and let's go down here and talk about that procedure. Okay, so the procedure would be to go back up to your original partial fractions and look at those denominators. If you're looking for convenient x values, and we define convenient x values to be any x value that causes one of the denominators or any denominator of a partial fraction to be 0. What you can do is you can take those denominators, set equal to 0, and then solve for x. So I would subtract 1 from both sides, I get x equals minus 1. Now, if you can determine the convenient x values without going through that procedure, then that is fine. All right? If you can't, here's the procedure. What about x minus 3? What would cause that denominator to equal 0? So you might be able to look at it and say, oh, I already know the answer is x equals positive 3. That's fine. Now, if you can't, you say, I really would like to have a procedure. How do I do that? Take that denominator, set an equation equal to 0, solve for x. Okay, I get x is equal to 3. Alright, so that step 4 says, let x be convenient x values to solve for the constants. Once you've determined what those convenient x values are, then we want to actually use them. So how do we use them? Alright, so this is step 4. Our convenient x values, we said, were x equals negative 1 and x equals, what was it, positive 3. Okay, so these are our convenient x values. What we're going to do is we're going to plug those x values into the equation that we just made. So 4 times x minus 8 equals a times x minus 3 plus b times x plus 1. Alright, so everywhere I have an x, I'm going to put a minus 1. Alright, so I'm going to simplify this. I get negative 4 minus 8 equals a times, was that negative 4, plus b times 0. Alright, so that's negative 12 is equal to, usually write that as like negative 4 times a plus 0, right? Because b times 0 is 0. So that's negative 12 equals negative 4a. And I'm going to divide both sides by negative 4. I get that 3 is equal to a. So this is actually one of our solutions. We wanted to know what A equals to, and by plugging in that convenient x value into that equation, we actually eliminate two of the variables, right? So we have three variables. We have x, we have b, and we have a. By plugging in that convenient x value, we actually eliminated b and x. So we only had one variable to solve for in the equation, and we were able to solve for that variable a. All right, let's do the same thing for our convenient x value of 3. So I'm going to plug in a 3 everywhere I have an x on the left side and the right side. Okay, 3 here, 3 here, 3 here. And I'm going to simplify. What is that? 12 minus 8 equals a times 0 plus b times 4. So 4 equals 0 plus 4b. Okay, we usually don't write 0, so we usually just 4 equals 4b. Okay, then I'm going to divide both sides by 4, and I get that 1 is equal to b. Alright, so we found actually both quantities that we were looking for. So let's go back up and say, okay, what have we actually found by finding the values of these letters? Okay, and so what we just found was the idea here. We said a was 3, so in place of a, I'm going to put a 3. So that goes on top of the x plus 1. Plus, we said b was 1 over x minus 3. Alright, that is actually what we call the partial fraction decomposition. These are the partial fractions that where if you added them together, you would obtain the original fraction that we started with. Alright. Alright, this is example 2 of partial fraction decomposition. Okay, step 1 of partial fraction decomposition is to factor the denominator. Alright, so I'm going to write this as 3 divided by. Let's factor out a common factor first of x. Alright, so I'm going to just do this right here. When I do that, I'm left with dividing each one of these by x. Let's see, I'm left with x squared. What is that? Minus 2x minus 8. Alright, so now I need to factor that a little bit more. So that trinomial there would factor as x times x. What do I need? Minus 4 positive 2. Alright, and if you need to, you can check that by foiling that out. Okay, you should get back to x squared minus 2x minus 8. Alright, I'll leave the check to you. But when I completely factor that denominator, these are the factors that I get. Alright, we notice that each of those factors is linear. So x to the power of 1, x to the power of 1 minus 4, x to the power of 1 plus 2. And they are only there one time. So this is a non-repeated linear factor problem, which we would call type 1. Alright, second step is to set up the equation. Okay, what do we mean by that? We're going to write our equal sign. Each one of those non-repeating linear factors is going to become the denominator of its own partial fraction. Now on top of the fractions for the numerators, I'm going to write capital A, capital B, and capital C. So that's what we call setting up the equation. Alright, step 3, we're going to multiply by the lowest common denominator, the LCD. Now what that means is that we're going to go back to the factor denominator and we're going to use that. So that's what we call our LCD. Alright, so I'm just going to recopy everything that I have. I'm going to give myself a little bit of room here in between the fractions. Alright, so I'm going to do x times x minus 4 times x plus 2 over 1. We're going to multiply that times every fraction. Alright, now if we've done that correctly, then all of our denominators should cancel out. So the x's cancel, x minus 4's cancel. Copy that down wrong. Let's go ahead and fix that. Should be x minus 4 here. There we go. So those should cancel. There we go. The x plus 2's cancel, and I'm left with just 3. Alright, from the a fraction, the x's cancel, and I'm left with a times x minus 4 times x plus 2. From the b fraction, the x minus 4 cancels, so I'm left with plus b times x plus 2. And then from the c fraction, the x plus 2 cancels with this x plus 2, and I'm left with c times x minus 4. Alright, so if we've done that correctly, then every denominator should cancel with a common factor in that LCD. Okay, step 4. We want to think about those convenient x values. Okay, remember, how do we find convenient x values? We think about what would it take to make each one of these denominators equal 0. Now remember that if you have a hard time eyeballing that, you can always take the denominator, right here's x, set it equal to 0, solve for x. X equals 0 is one of our convenient x values. Okay. Alright, another convenient x value, let's take that denominator, set it equal to 0, solve for x, add 4 to both sides to get x equals 4. So there's another convenient x value. And x plus 2, set that equal to 0, subtract 2 from both sides to get x equals negative 2. There's another convenient x value. Alright. Once we determine those convenient x values, we're going to plug them into the equation that we see up there. So let's do 0 first. Alright. Just going to do a little bit of simplification. You'll notice on this side, the left-hand side doesn't have an x value, so it's just going to stay 3. Okay, we'll simplify inside of the parentheses first. Okay. Negative 4 times 2 is negative 8. 0 times 2 is 0. 0 times negative 4 is 0. So I get negative 8 times a plus 0 plus 0. I can drop those zeros and I get negative 8a. Alright, I'm going to divide both sides by negative 8. And so I get that negative 3/8 is equal to a. So there's one of our solutions. And our goal is to figure out what are the values of a, b, and c. What are those numerators? Alright, I'm going to do the same thing for x equals 4. All right, do a little bit of simplification there. I'm going to simplify what's inside the parentheses. All right, we'll do our multiplication. 0 times 6 is 0, so that's a times 0. That's b times 24 plus c times 0. A times 0 is 0. That's 24b. That's 0. I'm going to drop the zeros, and I get 3 equals 24b. Okay, now I'm going to solve for b. I'm going to divide both sides by 24. I get 3 over 24 equals b. Now we always want to reduce those fractions. So I get 1 over 8 is equal to b. Okay, so there's another one of our final answers. Okay, the last convenient x value is -2. So I'm just going to plug in -2 everywhere I see an x. Alright, I'm going to start to simplify what's inside of the parentheses. Alright, so I combined those values inside, and I'm going to just do the multiplication. -6 times 0 is 0. Let's see here, -2 times 0 is 0. C times, let's see, -2 times -6 is a positive 12. So you get 0 plus 0 equals 12c. We can drop the zeros, and I get 12c on the right hand side. And the last thing I'm going to do there is solve for c by dividing both sides by 12. So I get 3 over 12 equals c. And once again, we always want to reduce our fractions. Dividing the top and the bottom by 3, I get 1/4. Okay, and there is the last value that we were looking for. So we found the values for a, b, and c. Now let's go back up and just take a peek at what our final answer would be there. Okay, so let's go back to our partial fractions. We had a over x. So a value, let's see, our a value was -3/8. So when I come back up here, that would be, in place of a, I would have -3/8. All right, and our b value, just go take a peek. Our b value was 1 over 8. So where I have the b, I'm going to put 1 over 8. And in place of c, we said that c was the value of, what was that, 1/4 when we simplified. Alright, so there would be our partial fractions. Alright, so -3/8 over x, 1/8 over x minus 4, plus 1/4 over x plus 2. Alright, now you can leave them just like that. That is fine with me. If you want to, sometimes people like to simplify that complex fraction. You can think about the denominators as fractions and flip and multiply them times the top, if you wished. That would give us -3 times 1 over 8x. And that would give us, what's that, 1 over x minus 4. So that would be 1 over 8 times x minus 4. And then flipping that fraction and multiplying, I would get 1 times 1, which is 1, and then 4 times x plus 2. Okay, and then if you want to, you can distribute into the parentheses. Overall, the final answer does not need to be simplified, and really all I'm looking for are what are those a, b, and c values. But If you don't want to simplify, that's fine. You can write your answer just like that. If you want to simplify, you can go as far as you can. Okay. Ultimately, what I'm interested in is what is the A, B, and C value. Okay.